Alright guys, this is a quick review of the Pythagorean Theorem. This is a formula that we can apply to right triangles. So, just like as is demonstrated in these two pictures, the Pythagorean Theorem applies to right triangles. You can see the right triangle in both of these images in the center. And what the Pythagorean Theorem says is that for any right triangle, the squares of the two legs, the two sides that are making the right angle, are equal to the square of the third side, the hypotenuse. So just a quick review of some vocabulary here. For any right triangle, there are two sides that create that right angle, and we call those the legs of the right triangle. There's a third side that's across from the right angle, and that's called your hypotenuse. So your hypotenuse is across from the right angle. One way to find it is to put your pencil or pen on the right angle and draw an arrow going across and find the side. That's the hypotenuse. It's also the longest side of a triangle. So it's the longest side, it's the one across from the right angle. The other two are the legs. So what the Pythagorean theorem says is that for any right triangle, such as this one right here, I'll redraw it in case it's hard to see, that has legs that are 3 and 4, and the hypotenuse is 5. For any of these right triangles, if I square the two legs, so they actually drew squares, but what the square right here means is 3 squared. That's why we call raising something to a power of 2 squaring it, because it forms an actual square when we draw it 3 by 3. So the square of these legs, so we have a 3 squared and a 4 squared. Those two added together will always equal the third side, or the hypotenuse, squared. So if I square the two legs, the 3 squared and the 4 squared, that will always add up to the same thing as the hypotenuse squared. So we'll test that out. 3 squared is 9, 4 squared is 16, 5 squared is 25. So 9 plus 16 is 25, so they equal each other. It works. That's another way to prove that a triangle is right. If this applies, if the two legs squared equals the third side squared, then you know you have a right triangle. So this theorem applies only to right triangles, and anytime you see this relationship, you know we're talking about a right triangle. Now, a common way to refer to it, if we look in this image over here where we have A, B, and C as our labels for our right triangle, is the Pythagorean theorem says that the two legs, which would be A squared and B squared, so the squares of the two legs, are always equal to the hypotenuse squared. So we say that A squared plus B squared is always equal to C squared. It's important to note that these are always the legs, and this is always the hypotenuse. So as long as you put the legs on the left side and the hypotenuse in place of C on the right side, you should be good to go. And what we use this for is two things. We'll use this either to determine if a triangle is right or not. So we can tell if it's a right triangle by checking to see if this is true. And we can also use it to find a missing side of a right triangle. So if we have a right triangle and we are missing a side, we have 2 but not the third, we can use the Pythagorean theorem to find the missing third side. So here's an example. Let's say this side is 6, this side is 8, and this side is unknown. So what we can do to find that unknown side is, because we have a right triangle, is we can use the Pythagorean theorem, which says a squared plus b squared equals c squared. And remember, A and B have to be legs. C is the hypotenuse. So if we look at our triangle, we need to know which one's which. Well, the legs are the ones that create the right angle. So in this case, the legs are 6 and 8. So 6 squared and 8 squared go here. It doesn't really matter which one's A and which one's B because we're adding. But they do both have to be on the left side. So you have to have the 6 and the 8 as A or B. And then C is the hypotenuse. This right here is the hypotenuse, so that's what we use for C. And we don't know it, so we leave it as C squared in our equation. And now we have everything we need to solve for that missing side. Now I just start solving. So 6 squared is 36, 8 squared is 64, that equals c squared. Now I add 36 and 64, and I get 100 equals c squared. Now that's not what the leg is. 100 is equal to c squared. The actual hypotenuse is c. So if 100 is c squared, then c is actually the square root of 100. In order to get what c is, I have to take the square root of 100. So c, that missing side, is 10. So we can do this with other right triangles. We do have to make sure that we have a right angle that's marked in order to use this, but otherwise we can use it to find any missing side of a right triangle. So let's look at another example here. Here's a right triangle. There's my right angle. And we'll mark a couple of the missing sides here. So let's go ahead and label one of these sides 5. And we'll label this one right here 13, and we need to figure out this missing angle. Okay, so we're going to rewrite Pythagorean Theorem all variables, and then start plugging in our numbers. Start with c. It's usually a good idea just to make sure you know which one's your hypotenuse, because that's where c has to be. Make sure you're labeling the correct one, the hypotenuse. So in this case, the hypotenuse is the one that does not create the right angle. So this is my hypotenuse. It's across from the right angle. So 13 is my c. So in my equation, I'll replace the c with a 13, 13 squared. Now 5 is a or b. It doesn't matter which one you call it. So I'll call it b. I'll plug it in for b. And a is unknown, so this side that we need to find is a. So now we start solving. Exponents first, so a squared plus 25 equals 169. You need a minute to do that, or take out a calculator if you don't know 13 squared. And then we start solving for a squared. So just like a normal equation, we subtract 25 both sides. And we end up with 144 equals a squared. Okay, that's not the side length. That's what a squared is. The side length is actually 8, so we need to figure out. If a squared is 144, then a is equal to the square root of 144. And the square root of 144 is 12. So that missing side length is 12. Okay, sometimes they don't always come out to whole numbers like this. This one happened to be the square root of 144, which is nice because it's 12. The other one was the square root of 100, so that worked out nicely too. But sometimes they don't work out that nicely. In that case, you'll have one of two options. We'll do another problem. Okay, so here's my right angle. So 5, 7, and we'll label that one unknown. So here's the Pythagorean theorem, a squared plus b squared equals c squared. And we're going to plug in our values now. C is the hypotenuse. That's the unknown value in this triangle. So the 5 and the 7 are a and b. It doesn't matter which one's which. So we'll just plug one in for a, 7 squared, plus 5 squared equals c, we don't know, so it's c squared. We start doing our problem, exponents first. 49 plus 25 equals c squared. And then we add these together. If you need to get a calculator out or do it off to the side real quick, we end up with 74 equals c squared. And then what we need to do is take the square root. In order to figure out what c is, we need to know what times itself gives us 74. That means our answer needs to be the square root of 74. Now, at this point, you have two options, and it depends on what your directions say is how you express your answer. One possible option is you just take the square root of 74 on your calculator. So you get out a calculator, there's really no other way to do that, and you type the square root of 74 in there. So if you can, get a calculator out. I'm going to get one out here too, and we're going to type in the square root of 74. And when I do that, I get that the square root of 74 is equal to about 8.6, and you can round it depending on how your teacher or your problems say to express your answer. I'll just do one decimal place, so it's 8.6. So that's one option. The other option, since this is a rounded answer, the other option is to give the answer as an exact answer, which to do the exact answer of the square root of 74, the only way to do that is to say, okay, C is the square root of 74. And you have to leave it as that. Now, if it were possible to simplify the square root of 74, you would need to simplify the square root of 74, but that's a different lesson. 74 can't be simplified anyhow. So that's it. When you're solving for the Pythagorean theorem, you're finding a missing side. If you happen to get a square root that doesn't have a whole number for an answer, it's not a perfect square, then you either type a decimal that you get from the calculator, or you leave it in radical form. That means the square root of 74, like we did here.